Let's find the angle x in the given picture. ABCD is a square, and there's a point inside the square, and the distance from this point to the vertices are like 2 root 2, and you have force. So this looks like this part looks like kind of symmetric, so we can use that. Maybe these two triangles are equal. You can prove that the triangles are equal. So basically, the first step to prove is just pay attention to this triangle. This triangle is exactly same as this triangle. So what I'm going to do is just like pick this triangle and place it over here. So these two triangles are equal. Just like cut out and then place it over here. And then the sides are the following, right? So now look, if you look at this angle, if you compute this angle, what will be the value of this angle? Since you have like x over here, this is 90 minus x, and this is also 90 minus x actually, since you cut that part and then put it over here. So this total angle is 90. So we have a 90-degree angle here. And if you draw this line, FE, this one, what will be the length of this one? Because like 2 root 2 here, 2 root 2 here, and then it's a 90-degree angle. What will be the length of FE? It's a Pythagorean theorem, or just like isosceles right triangle. So that gives me just 4. We need to multiply this by root of 2. Now, in this picture, we can notice that this is equilateral triangle, all fours. So first, yeah, so we have these 3 equal angles. So that's another thing. So we have equilateral triangle over here. And then if you look at this triangle, so this one is a copy of this one. And then these two are symmetric. So which means this part is also x. So basically, since these two are equal to each other, I can say that we have x here and then x here. So 2x. So if I know this angle, angle A, x will be half of that. So what are the angles of this green triangle? So since all sides are 4, this angle is 60, which means if I put the x's back, so these two have to be 30 and 30 in order to get the total 60. So the x is 30 degrees.